Welcome to ANS Solver question 10 of this paper. So the diagram shows a sketch of a curve with the following equation. We have to find the coordinates of A, B and C. Okay, so we know that A, B and C lie on either of the axes. So we already know one of the coordinates of each of the points. So for C, we know the x coordinate, that is 0. And for A and B, we know the y coordinate, that is 0. So now all we need to do is substitute these coordinates into the equation and we'll find the respective coordinate for each of the points. So let's start with point C, as that's the easiest. So if we substitute x with 0, we'll have 0 square plus 3 multiplied by 0 minus 4. So 0 square is 0 plus 3 multiplied by 0 is 0 and minus 4. So we'll be left with minus 4. So our y value for point C will be minus 4. Now let's move on to point A and B. To do that, we need to substitute y as 0. So we will have a quadratic equation in this case, that is x square plus 3x minus 4 is equal to 0. So now we need to find two numbers such that their product is negative 4 and their sum is positive 3. So that would be negative 1 and positive 4. So x square minus x plus 4x minus 4 is equal to 0. So now we can take what is common between the first two terms, that is x. So x square divided by x is x. Negative x divided by x is minus 1. Plus we can take 4 common in the second two terms. So if we take 4 common, 4x divided by 4 will give us x, and negative 4 divided by 4 will leave us with negative 1 equals to 0. Now two brackets would be x plus 4 and x minus 1 is equal to 0, and therefore the two values of x would be x is minus 4 and x is positive 1. So therefore we now have our coordinates for points A and B, the x coordinates. Now A lies to the left of or in the second quadrant where the x values are negative. So we know that negative 4 will be A's x coordinate and positive 1 will be B's coordinate, because B lies in the quadrant where x is positive. Now let's move to part A2, where they are asking us to differentiate the expression. So when you are differentiating any term in the form x raised to n, it will always equal to nx raised to n minus 1. So in this case we have x square, so x square will become 2x and 2 minus 1 is 1, so 2x raised to 1. Now for 3x we do the same thing. So 3x will be equal to 1 will come down, so 3 multiplied by 1 is 3 and it will become x raised to 0. So x raised to 0 is 1, therefore 3 multiplied by 1 will be 3. Now whenever there's a number that you need to differentiate, in this case minus 4, that number will become 0. So therefore your final answer will be 2x plus 3. Now let's move to A part 3, where they ask you to find the equation of the tangent to the curve at the point 2, 6. So to find the gradient of the curve or of the tangent, all you need to do is substitute the x value of the point into the differentiated expression of the original equation. So 2 times the x value, which is 2, plus 3 will give you the gradient of the tangent. So 2 times 2 is 4 plus 3 will be equal to 7. So we have the equation of the curve now, which is y is equal to 7x plus c. Now we need to find the value of c, which is the y-intercept. So all you need to do is substitute this point into the equation. So y is 6 when x is 2 plus c. So all you need to do is solve this equation for c. So therefore c will be equal to 6 minus 14, because 7 times 2 is 14, and when you take positive to the other side of the equation, it becomes a negative. So therefore C, or your C value, will be negative 8. Therefore your equation, or the equation of the tangent will be y is equal to 7x minus 8, and therefore this will be your final answer for A part 3. Now let's move on to part B of this question. So they have asked you to draw the curve tan x. So this is just a sketch graph, so it can be as rough as you, not as rough, but kind of exact, like how I have done it. It should look like the tan curve. So this is how the tan graph looks like between 0 to 360. So this is really easy to draw, so you can do this. Now let's move on to B part 2, where they ask you to solve the equation 5 tan x is equal to negative 7. Okay, so you can take 5 to the other side of the equation, so we will be left with tan x is equal to negative 7 by 5. So therefore x will be equal to tan inverse of negative 7 by 5, and therefore your x value will be tan inverse of negative 7 by 5, negative 54.462322. Now this is not your final answer, because the tan value in this case is negative, and in the 4 quadrants where or the trigonometric quadrants, that is where all of them are positive in the first quadrant, sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. But in this case tan is negative. So when tan is positive, you would take the two values that would be positive in the all quadrant and in the tan quadrant. But since it is negative, you will take the two values, so in the cos quadrant and in the sine quadrant. So one of the theta values will be equal to 360 plus x, and the other theta value will be equal to 180 plus minus x. So all you need to do now is input this calculation into your calculator. So 360 plus x will give you the value of theta as 305.5376, and 180 minus x will give you the value of theta as 234.4623. And since you have to give your answer in 3 significant figures, your first value of theta will be 306, because your fourth significant figure, which is 5, and 5 is greater than or equal to 6, so it will round off the third significant figure to the next number. But for the second theta value, you will leave it as 234 degrees, because the fourth significant figure is 4, which is lesser than or equal to 5, so it won't round off the third significant figure to the next digit. Therefore these will be your final answers for question 10.